In this video, I'm going to look at two applications of radicals. One of them is the Pythagorean theorem. It's a theorem you may have seen in geometry that says if you have a triangle that is a right triangle, meaning a 90-degree angle right there, then you know if you take the shorter sides and square them and add them up, has to equal the length of the longer side. The longer side is always the side opposite the right angle. So the problem on the worksheet like this is number 14, okay? All right, so on that one, you have a triangle that looks like this, and your job is to find B. So you start by setting it up, and 8 is the longest side, so it should be on the side by itself. So you wind up with an equation that's actually a quadratic equation without a middle term. So this really could have been back in the previous unit. So we'll subtract 64 and we wind up with b squared equaling 60. Then we're going to come in and we're going to square root both sides. And we wind up with b equaling plus or minus. And with 60, we'll break it down until we get it factored all the way. And we find out it has a pair of 2's. So it'll be 2 and then square root of 15. All right, now this is an application problem that's talking about the lengths of the sides of a triangle. So it has to just be the positive one. Okay, so the answer actually for this would just be 2 square root of 15. And that's the simplest radical form for that. Okay, now the other application is actually going to use the Pythagorean theorem. They just write it in a different way. The other application problem is looking at how to find the distance of a line passing through 2 points. So, you label the points kind of like you do with when you learn the slope formula. And what we're going to do is we're going to figure out the length of this line segment right here. So if you think about the horizontal and the vertical line here, that little triangle we sometimes used when we were doing slope, the length of this side would be y2 minus y1. The length of this side would be x2 minus x1. And see, that's a right triangle. So the distance formula really comes from that idea. If you took the x2 minus x1 and squared it, let me write that 2 where it's supposed to be. That's a subscript, not a superscript. x2 minus x1 and squared it. And then if you did y2 minus y1, squared that, that would equal this. This is what we're looking for. This is the D. Okay, so we're looking for that distance. All right, let me get that back on there. All right, so we know that the distance squared, the longest side, has to equal this. And so we want the square root of all of that. But then because it's an application problem, we don't want the negative one, so that's why you don't normally see that. That's normally not there because we want just the positive one. All right, so we're going to look at question number 15. On 15, they want the distance between these 2 points. Okay. So what we're going to do is we're going to plug into the formula. And the formula is very forgiving. It doesn't matter really which point's the first point or the second point. It doesn't even matter if you subtract in the same order like it did with slope, because things are getting squared right here. So even if you subtract these backwards from those, you're going to get the correct answer. So as long as you keep the x's together, so 4 minus the 2, and then keep the y's together, doesn't really matter if you do it in the same order or not. But make sure you're subtracting those. Okay, and square that, add it together, take the square root of the whole thing. All right, so let's finish this one up. So that would be 4 minus 2. That's going to be 2. This is negative 2 minus negative 6, which becomes plus 6. So that becomes a 4 squared. Square root on all of that. Okay. So we wind up with the square root of 4 plus 16, and don't square root each of those. That would not be correct. So this is a grouping symbol. You have to do what's underneath it first. So you'll get a 20. You take 20 and break it down, and you find out it's 2 times 2 times 5. So that means there'll be a 2 on the outside and a 5 underneath. And that would be your final answer on that one. Okay. So I'm going to stop here. That's 14 and 15, the two application problems. So you might find this helpful when you're working something similar in MyMathLab.